Can you shut that back door? Well, greetings, Earthlings. Everyone wide awake? No, partially. John, how are you doing back there? You all sound so enthusiastic.
It's Wednesday. Yeah, it's Wednesday. Someday.
We're going to talk about EIGRP. Well, actually, you're on the second half of the week anyway. We're going to talk about IGRP, EIGRP. This is going to focus a lot about EIGRP, but IGRP is the same thing. This just has more functionality, all right? I couldn't find the slides for IGRP anywhere. We're going to talk about the background and history of EIGRP. We're going to talk about the basic configuration commands, calculate the composite metric, and describe the components or the concepts and the operation of dual, and talk about additional commands for EIGRP. Well, EIGRP is a distance vector protocol based on classless networking. Remember, like I told you, RIP and IGRP were before we had the subnetting issues, where we had all the IPs in the world. Then we didn't. They went to RIP version 2 and EIGRP, which is enhanced IGRP. And then OSPF version 2. So we'll start talking about a little bit of these. But I'm not going to worry about OSPF this time. The roots of EIGRP. IGRP came out with RIP version 1 in 1985. The metrics were bandwidth and delay, just like RIP version 1, but it also added reliability and load. They discontinued starting using IGRP in 12.2, the iOS. In 1992, EIGRP was started and released 9.2 to kind of give some people, get them time to learn it. You don't want to just throw something out and say, here's Windows 8. We discontinue services for Windows 7 and before. Everyone would have flipped. They would have lost market shares, right? Which they already practically did with Windows 8. Who in their right mind wanted to make it a tablet operating system for desktops? I don't know. But anyway, that's why in the SDLC lifecycle, you want to make sure that you're still backwards compatible. And so that's what iOS was doing. The IGRP message format comes in a message header, just like everything else. You're gonna and it comes on layer 2, the data link layer, right? Because that's where you do all your packet or your frames. And it's going to tell you where the source and destination MAC address is, right? Y'all remember that? We've talked about it several times. The IP packet, which is engrossed inside of the frame, also contains the source and destination IP addresses. The EIGRP packet header that is added onto it contains an AS number. Then you have the type, field length, and the rest of the EIGRP message. Okay? What is an AS number? It's the autonomous system number. All right? So when we get into the coding here in just a minute, you'll understand what an autonomous system number is. Time to live, internal and external messages, or just metrics that are actually in these frames. Then you also have the protocol dependent modules, or the PDMs. EIGRP uses PDM to route several different types of packets: IP, IPX, and AppleTalk. What's the difference between the three? Which one's still in use? Which ones are not? AppleTalk still is. IPX still is. They're used about that much. And those are legacy systems. PDMs are responsible for specifically routing the task to each network layer. Okay. Basically, RTP, which is a reliable transport protocol, all it did was take EIGRP to transmit and receive those EIGRP packets, right? You needed the protocol to understand what the packets read. Pretty simple. RTP gives you reliability and unreliability of the delivery of the packages, i.e. IP addresses. What is an IP? Is it reliable or is it unreliable? Y'all tell me. IP. We just talked about it. It's reliable. UDP IPX is unreliable because there's no connection. Remember, IP is connection oriented, therefore it's reliable. Packets can be sent both in unicast and multicast. And EIGRP will send hello packets just to discover and find out who's out there. That's how it does discovery. It'll send update packages, but then it also requests an acknowledgement packet that they got the update packet. What happens if they don't get the acknowledgement? It's going to resend the packet. I said, Brent. Okay, he acknowledged me. I know he got the packet. I said, Kristen. And she just looks at me. I don't know she got the packet. So I just resend it, Kristen! You know, you get louder and louder. Kind of like John Jacob Jingleheimer Schmidt. Except in reverse order. John liked that one, didn't you? You probably got that one quite a bit when you were a kid, didn't you?
No.
Or you didn't sing that a lot?
I went by my middle name. So.
Oh, did you? I didn't even think about John Jacob. Well, I was just thinking your first name when I said when we were talking about John Jacob Jingleheimer Schmidt. I was just thinking John, and that's why, not John Jacob. And then I just realized, oh yeah, it's your last name. Sorry about that. Wasn't trying to make a pun on you.
You're all right.
That's okay. If you've been on the trips with us, you'd understand. Cameron will tell you, our puns were utterly ridiculous. Only Aaron, Todd, Cameron, Aaron, and Cody all understood that joke. Never mind. I was going to go there, but I decided not to. Query and reply packets. Basically, if I'm going to query you, I would expect a response. If I say, Cole, what's your name?
Cole.
Well, that kind of be redundant, wouldn't it? But, what's your name?
Cole.
There you go.
There you go.
I can use unicast and multicast, but the reply will always be a unicast. Why? Why would the reply be a unicast, not a multicast? Because you're replying back to the person that said it. If I sent out a multicast message and said, Kevin, okay, I've got Todd, I've got Jackson, Brent, I mean, just all of y'all just kind of started looking at me. Todd looked at me. I sent out a multicast address. The only one that would respond should be Kevin, right? Unless you have two Kevins in the room. Then they'll both look at you, and they'll look at each other. But the response coming back would be unicast. Now, I can send it, if I know where Brent is, I can send a unicast message to Brent, no one else will hear it. Does that make sense? The purpose of a hello protocol. Basically, it's just saying, I want to know who my neighbors are. So if I said hello, I guess I have no neighbors. Oh, hi, Jackson. Okay. Do you realize that EIGRP sends out hello packets every 5 seconds? Aren't you glad there's a router and not a human? It kind of that. Well, actually, it almost sounded like Matthew Bailey in the car, didn't it?
I think he's a rider in disguise.
He probably is. Anyway, sorry. EIGRP bounded updates. We'll only send if you have something that's changed. If a route has changed, that's the only time it sends it out. It can send out a partial update where it gives you partially information that was updated. Or it give you a bounded update where it sends everything to those that would be impacted by that route. Kristen, tell me about the dual algorithm.
No, I don't know the dual. We're learning about it. Like, I have no idea.
The dual algorithm. It's EIGRP's way of preventing loops.
No, I couldn't have read it because he would have said that's the thing. Aaron's back talking.
Aaron, what's an advantage of dual? What is an advantage of dual?
Short and to the point.
Yes, you're right. It's faster. It makes sure that there is no loops. What is administrative distance? We talked about the administrative distance table earlier. We have EIGRP summary routes. The administrative distance is 5. Means it's going to get there quick. It just wants to make sure that everyone knows where it's at. Internal EIGRPs will be 90 and externals 170. Why is that important? Why is it important? Because you want to say you have the trustworthiness of that route. You know it's authentic. Talking about authentication, EIGRP can encrypt routing information and authenticate it. Ding, ding, ding. Are y'all starting to catch on now why you want to use EIGRP? What about IGRP that sends it in clear text? Or RIP version 1 that sends it in clear text? Let me put a vampire tap on your network and see how long it takes me to take you down. Okay? Network topologies. Topology can be same in the previous chapters. With an ISP router in there, you have multiple routers. Okay? The packet tracer is going to look just like this. Well, similar, right? EIGRP will automatically summarize those classless routes for you, or classful routes for you. Isn't that nice? Don't y'all love that when things do it easier for you? Didn't I tell you all that before RIP version 2 last week? How many of y'all have tried to... How many of y'all did RIP version 2? Well, if you turned in your homework this weekend, you did. The autonomous system and process IDs. Basically, all it is just a specific number that you refer to for that ISP or a different area. You're just giving it a number. All right. It's easier to identify. I want to send a summary route to this autonomous system. It's like a virtual environment. Does that make sense to you? You're kind of understanding the... It really doesn't matter other than saying, here's what my autonomous system number is for this network. Your autonomous system numbers are assigned by the IANA. They're mainly for your backbone providers and institutions that need AESs. Why does it go by the IANA? Because you can't have two of the same autonomous system numbers. EIGRP autonomous system number actually functions as a process ID. How many of y'all familiar with process IDs? What you have to do is your command is going to be router, EIGRP, and then a number. That number is from 1 to 65,536. All right. And all routers in that same domain have to use that same autonomous number. Otherwise, the routing tables get screwed up. Network commands. Enables interfaces to transmit and receive EIGRP updates. It includes subnets because it can be classful routing, right? Classless routing, I mean. Everyone with me? Let me get back here. The network command. If I'm giving my networks for EIGRP, that's fine, right? But if I want to give it a wildcard mask, anyone know what a wildcard mask is? That's the opposite of 255, 225, 225, 225. If you want to know what your wildcard mask is, you're going to get to know this when you start talking about ACLs, access control list. If those that are going to take the advanced routing class with me in the fall. Okay. A wildcard is you take your subnet mask and subtract it from a full octet of subnets. If everything's turned on, 255, 255, 255, 255, you take your subnet mask, subtract it from it, and that gives you your wildcard mask. It will blow your mind, trust me. Don't get too caught up on it now. I'm just explaining what it is. All right. If you wanted it, like for down here where you see 192.168.10.8, if I wanted that small network segment, right? I want it to go, my next network is .12, and I only want it to look for the .8 network, I have to put the wildcard mask in there as 0003. Now you kind of understand how you do it. EIGRP will show, when you say show EIGRP neighbor or IP EIGRP neighbors, it'll show you how long those connections have been and what interface they're going out. How long, if it's over 10 seconds, that it's down. Okay? It'll wait 10 seconds if it hadn't heard anything, then it says it's down. Here's your link time, what your uptime is. Show IP protocols. It'll start listing them. EIGRP gives you your internal and your external. It tells you all your mappings, your auto summarizations. So it's very important that you realize that. Show IP route. Again, what happens if I have a D? What does D mean? D, right here, is not direct connect. C is direct connect. D is EIGRP. I don't know why they just didn't leave it as an E, but null, 0. If you see this right here where it has null 0, those are summary routes, not a physical interface. There's no such thing as null 0. You have to have two things have to happen in order for you to get that to. You have to have auto summarization, and at least one subnet has to be learned by EIGRP. Everyone with me? R3's routing table will show 172.16.0.0 on the 16 network. The network is automatically summarized by R1 and R3. Okay, R1 and R3, right? Thus now I have this summary right here to null. Well, we just talked about null. Anyway, I'm sorry, that's your basic EIGRP. All I have to do is say 172.16.0.0, and if I have 172.16.0.0, I guess I'm on R2, or I'm on R3. 172.16.0.0. Okay, because I have this network and this network. And if I summarize it on here, it's going to give me the equal cost to get out to this network. All right. The composite metric, don't worry about it. Use the show IP protocols to verify the metrics, which I'm not going to talk to you about. I'm not going to talk about metric calculations because you don't need to know them. Again, come on. Dual. Diffusing update algorithm is used to prevent loops, right? Loop-free paths, loop-free backup paths, fast convergence, minimum bandwidth. All sounds good, right? Successor. Beat the least cost route to the destination found in the routing table. So instead of going, that may be my feasible distance, but here's my successor. Basically, it allows you to prevent loops by saying, instead of getting in this loop, go to this network and here you go. All right. The reported distance will come back and it may change this if there's something different. Feasibility condition is met when the neighbor's RD is less than the local router's RD or FD to the same network. Am I becoming monotone tonight? Kristen says yes. I'm not going to cover more on dual. Okay, the null zero summary route. You have to have auto summary on, right? And one has to be auto corrected or auto done. The auto summary command permits the IGRP to automatically summarize all major network boundaries. No auto summary. What do you think it does? Bye bye. It gets rid of it. But if you say no auto summary, it's going to screw up your routing tables.
Good to know.
So what's the purpose of doing it? If I'm going to get rid of EIGRP and put in version 2 or something like that. Manual summarization. I can make it to do what I want to do it. Command to configure manual summarization. IP, summary dash address, EIGRP, the AS number, network address, and subnet mask. So basically you would say IP summary address, EIGRP 101, 192.168.10.000.255. Or actually subnet mask 255.255.255.0. Make sense? EIGRP default routes. Quad 0. Static default route. Remember what is quad 0? 0, 0, 0, 0. Brent? 0, 0, 0, 0. You got it down? Okay. Fine tuning it. You can create bandwidth and say bandwidth of 64 is one you're going to use. Basically, I'm saying my bandwidth is only going to have a ratio of 64% of the max. So I'm only going to use 64% of that bandwidth for traffic. You really want to throttle people down? The hello interval, remember it was at 10. You can change it to whatever you want to do it. You can go to 60 or 180 or whatever. All right, makes sense? Any questions? Other than blowing your mind with EIGRP? None?